Hello everyone, this is Saurabh Mitra, 16BEE1039 operating system class. Welcome to a video on how to build a modern computer from first principles. Today our focus would be on the project 5, 6, 7 and 8 of nand2tetris. Keeping that in mind, let's start. So moving on, project 5. Though the previous projects from 1 to 4, one should have successfully implemented the computer's basics, processing and storage devices, arithmetic logical unit and RAM respectively. In this project, we will put everything together, yielding the complete hack hardware platform. The result will be general purpose computer that can run programs written in the hack machine language. So the first one is memory hack. This chip implements the complete address space of the computer's data memory. It outputs the value stored at the memory location specified by the address. We would implement this and follow on the screen instruction. So what we have here is, we have the input pins, we have the output pins, as you can see on the file. On your right hand side we have the script, entire script. You can see the script is there. At the upper part of the script you can see it's loading memory.stl. That is your lower side. There is STL file, that is your brain, that is your chip, through which it will evaluate every expression. So now we'll go through the code. See it executing. As you see, it's executing line by line. And now we have to give K as input from the keyboard, virtual keyboard. Now it will be asking for capital Y as the input. So we'll give that. And the comparisons ended successfully. So now you can go to the output window from format, from view window, output. So you can see this is our output, and this output it is comparing with the compare window. If both are same, then it is showing the script is successfully executed. Okay. So now moving on to the next part, we have CPU hack. The CPU consists of two registers named A and D, and as program counter. The CPU is designed to fetch and execute instructions written in the hack machine language. So we have the CPU.htl, as you can see. Same thing. We'll go through run the program. So again you can see it's going line by line. You can see the internal pins. It's changing automatically as the program is proceeding. So here again we are getting a successful result. Now moving on, the next one is add.hack. So this is responsible for adding two numbers, 2 and 3, and storing the result in RAM of 0. So we are running the code. So the same computer.htl file will be using, and here we are getting the output. We can see the output at the output window. So you see time, reset, A register, D registers values, RAM 6K of 0, RAM 6K of 1, RAM 6K of 2. Okay. So it's comparing with the compare windows. Since both the windows are having same value, same set of values, our script is showing a script is successfully executed. Moving on to the next one, we have max.hack. So this takes two number at RAM 0 and RAM 1 position, computes the maximum and writes the maximum in RAM of 2. So here is the code. You can see it's running perfectly and we are getting a successful result. So we'll do the same thing again. We'll go check the output. Yeah, we are getting the output, no errors. And we'll go and check the compare screen. So you can see the compare screen is also the same. Since both the set of values are same, we are getting a successful result. So now this is all about project 5. Oh, okay, I'm sorry, there's one more thing left. It's rect.hack. So this code is draw a rectangle of width 16 and length provided is in RAM 0 on the top left corner of the screen. So we'll run the program and we'll show you the output. So we'll go to the screen from view window. You can see a rectangle over here, small rectangle over here, and you can see the RAM location and values. Everything is there, RAM location values and ROM location and value. So you're getting the small rectangle. So this is all about our project 5. now moving on to the next project, this is project number 6. So the objective of this project is to write an assembler program that translates programs written in the symbolic hack assembly language into binary code that can be executed on the hack compare platform. So the first one of this project is add.asm. It adds up the constant 2 and 3 and puts the result in unknown. So now we'll proceed through it line by line. Line by line we'll proceed through it. So as you can see, it's loading 2. Here you can see it's a 2 value. Next it's loading next line, it's loading 3. It's loading 3 here, and the final value will be the last line of the destination window. You're getting the final addition. Now next one, moving to the next one, it's max.asm. This simple code is used to compute max of R0 and R and puts the result in R2. So you are as you can see, the code again starts from when I come. It's at R0, it's taking the value. So far we are getting no error. It's successfully executing. And at the last we get we got the output. Right? So the next one is rect.asm. Draws a rectangle at the top left corner of the screen. The width is 16 pixel wide and R0 pixel is high. So we'll run it. It's a little bit slow because it's executing line by line. It's just taking one line at a time and then it executes and move on to the next line. So we have to wait a little bit until it finishes. See, there is a compilation successful. Let's message written over there. We are getting the output with no errors. So now moving on, we have project 7. So here we will be implementing certain components from project 7. The objective of this project is to build a VM translator, focusing on the implementation of the VM language, stack, arithmetic and memory access commands. We have got some simple arithmetic commands followed by some memory access commands for the VM translators. So now we have the first one as a simple add. So this code will push two constants into the stack and add them up. So here you can see stack. So here you can see the load simple add.vm is there. Now on the left hand side you can see the program constants here. So it's pushing constant 7 and push constant 8 into the stack and then it will add it up. So yes, so check at 256 it has 7, earlier it has 7, now it's changed to 8 because it added up. Okay, so here we are getting a successful message also, so successfully done the executing the program. Next, moving on, we have stack tst. There is a set of data provided within the program. This program would execute a sequence of arithmetic and logical operations on the stack and this data. So here we have stack test.vm. We have the file. We have on the left hand side you can see every push operation, what the arithmetic operation is doing, everything you have. It's running sequentially one by one. You can check on the global stack that the cursor is moving up and down. And now finally we got the output at minus 256, and then the RAM location SP counter will be stack pointer is 266. Okay. Now moving on to the next one, we have basic test. So execute push and pop operation using the virtual memory segment constants, local arguments, this, that, and temp. So in this program you see every instruction that I said earlier. Every instruction will be executed one by one. So here we are using a loop, or you can say it's a loop. We are using a repeat keyword for repeating the same instruction 25 times, and we'll get the output at 256, that is 472. You can also see the final output on the left hand side. That stack pointer is there. It's written 472, and on the down it's written successfully executed. So now moving to the second last pointer test. As the name suggests, this program executes push and pop operation using the virtual memory segment pointer, this and that. So we will simply run it and see the final output what it is giving. So here we are getting at 256, we are getting 6084, and the final stack pointer is at 257. Now the last one of project 7, stack test. Execute push and pop operation using the static machine segment stack. I'm sorry, it's a static test. We are doing static test now. So as you can see here, we are getting the output at 256 location 11110. You can also check the final output at the left hand side place where it's written 1110. So you're getting the output. The stack pointer is pointing to a 257 memory location. You can see that on the global stack region also, and we are successfully executing the program. So now this is the end of project 7, and now we will start discussing about project 8. So what is the main objective of project 8? It extends the basic VM translator built in the project 7 into a full-scale VM translator. So earlier what we have seen in project 7 is all about arithmetic and memory access commands of VM language. Now in this project we will look into the VM's language branching and function calling commands. So the project 8 has two parts. One is branching commands and one is function call and return commands. So in branching commands we have basic loop and Fibonacci series. So in basic loop we will just compute the sum of 1 to n and push the result into the memory stack. Commands that we will be using here is go to and if go to. So now we will run it, we will see the output it is giving. So you can see it's running a loop 33 times. On the left hand side you can see the pointer at the interpreter is going up and down because it's in a loop, and finally we got the output as 6. So that is at the 256 memory location, and the stack pointer is pointing at 257 location. Okay, so it's successfully executed, and the next program will be running is Fibonacci series. So in Fibonacci series it computes and stores in the memory the first n elements of the Fibonacci series. So we'll do the same thing. We'll just load the script file and we'll run it. Here you can see it's a loop of 73 times it will run, and we need to wait a little bit. We got the output. You can see in the output window you got the output as everything is mentioned, and what is the value at RAM of 3000, RAM of 3001. From 3000 to 3005 in RAM location you will get the output. So this is the output window. In the compile window you are getting the same value since both are same, so no error, and the program successfully ended. Okay. Moving to the second part of the project 8, that is function call and return. So here we have 4 things: simple function, nested call, Fibonacci, and static test. The first one we will do is simple function. So what is simple function? It performs simple call and return the result. So very simple. So we'll just load the script and run it. So here you can see there's a loop of 10 and it's running just like that. It's over. So we have at 310 location we have 1196, and at 311 where the stack pointer is pointing we have 37. You can see the output window for the values that you got from 0 to 10. In the compile window we will have the same values, same set of values, both the values are same, so no error, successfully. Next one is nested call. So for nested call we have test several requirements of the function calling protocols. So we'll just do the same thing. So here we have 50 loops, and now you can see on the left hand side you are getting the stack. You get the output there, the final output of the value. So it's over, and you got the final output from RAM 0 to 6th position. Compile window also consists of same set of values, no error. You got the output. You can see here the stack pointer and the memory location is same, 261, where the value is 246. Next one, moving on to Fibonacci. In Fibonacci we have two files, main.vm and system.vm. Main.vm contains recursive function system.vm. The function n equals to 4 where loops is indefinite. So now we'll run the Fibonacci element.txt script file. Okay, it's loading. It's 10 times it will run. It's in the loop. You can see the stack pointer is moving up and down, up and down. They depend upon the program commands that is written over on the left hand side. You can see there also it is moving up and down. There are various operations following like push, pop, gate, go to. Okay, checking whether it is big, whether the given number is greater than the next number or not. Everything is performing there. And finally we have the output. We got the output as 3 on the stack on the left hand side. Down the program counter you can see the output, and on the right hand side as you can see the stack pointer location and the previous line 261.3. Okay, so you got that. So for successfully run, the final test of project 8 is static test. So static test consists of 2 classes, class 1, class 2, contains function to set and get various static values. So we'll do it. So it's 36 loops will run, and on the left hand side you will see there is the values we are getting, and it's okay. So it print the final value, that is -2 and 8. Here also the global stack window you can see, and in the output window you can also see RAM from location 0 to 262. You are getting the values 263, 8, 260, -2 and 8. The same thing is printed over stack also. So this concludes this video. Thanks for watching.